1 second here. I gotta organize my paperwork. All right, so I put the answers to the review sheet on Canvas for you. It gave you a notification, right? Or no? So if you didn't get it, it's on Canvas for you. I think I put it on yesterday. So so you have the answers. Now we're still going to go over it, but at least you have it. So if you don't want to rush to copy everything down, you can just know that it's already on Canvas for you. It looks like this. Now in my morning class at Cal State Fullerton, at first I started just going over it like this, just like saying, all right, so you got this, then it's this, then it's this. And I noticed people are still writing it down anyway. So they preferred that I just go over it step by step live. So I'll do that. But just want to let you know it's all here on Canvas for you. So if you don't catch a part of my writing and you just want to pay attention, and you can just always write it down. You can write it down still, I'll slow down. But so let's go over the review sheet. And then after I go over the review sheet, I'll answer additional questions and I'll tell you answer any other questions. So let's say number 1 is g of x equals e to the 4x cubed times the natural log of x. Now, hopefully you attempt to do these yourself first. You're not just waiting for me to go over them. Right? What happened? No videos on. Half of you have it off. Daniel, especially you, I expected better from you. Not Daniel Chacon, I'm talking about.
There you go, sorry.
That's okay. Rest of the people. Okay. Hey, Madison, how are you doing? Good weekend?
Yeah, pretty good.
Hey,
mainly homework.
Oh, okay. Hey, so I had a question. Are you going to take more German when you transfer?
Well, I finished all the German classes here. I might, but I think I want to learn a different language, since I already finished German. So probably not.
Oh, but I thought you were going to major in German.
I majored in German because I technically finished all the classes. And so when you finish the classes, you major in German. But like my main focus is political science. I just happened to take enough classes to get a major in German.
Oh, okay. Well, major here, but like I'm at like undergrad when you transfer to university.
Yeah, I'm not going to major in German when I transfer in undergrad. I'll probably do either, probably not, maybe political science or something along that like lane.
Oh, you want to go into law? Just be a boring attorney?
Yep, that's the plan. Being super boring. No, I kind of want to go into politics, hence the political science part. Yeah, being boring sounds fun.
Yeah. So, find the derivatives. So, this is a product, so we're going to use the product rule. First times the derivative of the second plus second times the derivative of the first. What's the derivative of e to the 4x cubed? Is itself times the derivative of the exponent. What's the derivative of 4x cubed? 12x squared. And that's it. If I say do not simplify on certain questions, you just leave it like that. That's fine. So that was number 1 from the review sheet. Now number 2, f of x equals tangent of x to the fourth plus 2x plus 1. Now, key here is this is not tangent times. It's tangent of. So don't confuse that like on the first test. This is not this. This would be tangent of x times what's in the parentheses. Then you would have to use the product rule. But this question is tangent of that. So tangent by itself, if I just wrote TAN, that means nothing by itself, but it's tangent of u. What's the derivative of tangent of u? Secant squared of u times the derivative of u. That's the chain rule part. So keep that in mind. So let's go ahead and do this problem now over here. So the derivative is secant squared of whatever is inside the parentheses times the derivative of what's inside the parentheses. That's your u, which is 4x cubed plus 2. All right, let's move along to number 3. H of x is equal to log base 3 of e to the x plus 5. So the derivative, so I would say when you're doing this, just pretend like it's a natural log initially. Then at the end, you're going to make one additional step here. So if it was ln of the parentheses, remember what you're taking a log of goes on the bottom. Its derivative goes on top. What's the derivative of e to the x plus 5? It's e to the x. Now, normally you would be done, but because it's log base 3, you got to go times ln of 3 in the denominator. So this 3 right here makes you multiply by ln of 3 in the denominator. And we're done. So if it was log base 4, you put an ln of 4. If it was natural log, you don't put anything, because it's ln of e, which is just 1. Number 4, y equals 3 to the x times x to the 5th. So this is a product, right? Clearly it's a multiplication, so you got to use the product rule. First times the derivative of the second plus second times the derivative of the first. Does anyone remember what the derivative of 3 to the x is? It's itself times ln of the base, right? Any questions on that? So again, let me explain. So this is if you treat this as the first part and this is the second part. So this is first times the derivative of the second plus second times the derivative of the first. So notice the derivative of the first. So the derivative of 3 to the x is 3 to the x times ln of 3. So remember the rule for exponential functions. All right, number 5. Will that be the case every time there's something to the x? Yeah. So to answer your question, yes. If I ask you to take the derivative of 2 to the x, it would be 2 to the x times ln of 2. 3 to the x, the derivative is 3 to the x times ln of 3. Just the reason why e to the x is just e to the x is because if you go times ln of e is just 1, so you just say e to the x. See, that's why we don't even bother mentioning e ln of e. And does that make sense? Yeah. All right. So going to number 5. Y equals natural log of secant of x. The derivative is what you're getting the log of goes on the bottom, so secant of x. Remember I did the happy face example? If you have natural log of happy face goes on the bottom, the derivative of happy face goes on top. So what's the derivative of secant x? Secant x tangent x. And here you can cancel out the secants. So the answer is just tangent of x. Lauren, how are we doing today? What city, what country are we in today?
Still in Orange County.
Oh, before you were in Vegas, you were in Mexico. Now it's just boring Orange County.
Yeah, no boring. Staying safe. I was supposed to go to Miami, but with everything being crazy, I decided to pull out last minute.
Oh, you mean for vacation?
Yeah.
Oh, okay. Yeah, I actually read on the, not on the news, on the, where did I see it? Aren't they having an emergency in Florida with all the spring breakers in South Beach?
Yeah, I think they're like setting a new curfew like at 8 p.m. And if people are like out, they're like arresting them. I'm not too sure. I don't really know, but I got scared, so I decided to stay home.
I think in the summer it should be okay. Once, I think by May, pretty much, I think most people should be able to get the vaccine by then. So June, things open up more. We're hoping.
Hopefully.
Number 6. Y equals x times the arctangent of 4x. Now, before I do number 6, now this is a product where you got to use the product rule. Because you got this guy times this guy. So the main function is a product, but let's be honest, what the challenge here is that arctangent. So let me review that. If you have arctangent of u, so suppose you have that, the derivative of that would be 1 over 1 plus u squared, and then the change times the derivative of u. Keep that in mind. So going here, the derivative of that, you gotta go first, times the derivative of arctangent times the derivative of second. What's the derivative of arctangent? 1 over 1 plus u in this case is 4x squared times the derivative of u, which is 4. Plus second times the derivative of first, which is 1. So you got first times the derivative of second plus second times the derivative of first. Now, it's very simple, but there's much you can do on top here. X times 1 times 4 is 4x over 1 plus 16x squared plus the inverse tangent function of 4x. That's it. So someone asked, what about it on the top line, like if you left it like this, and it says, well, the direction is not possible by x, I'd give it to you. Right, otherwise, Madison, who's coming out of attorney or not, political politics. But people who go to politics are becoming attorneys. A lot of politicians are attorneys. That's why the country is messed up. I'm kidding. That was hard. Like, hey, if I had more people, like more senators and congressmen or congresspeople or presidents and vice presidents be like scientists, doctors, engineers, as opposed to attorneys, maybe the country would be run better. And then at that time, one of the candidates was in 2016, Dr. Ben Carson. I'm all like, oh no, that's not a good example of a doctor. All right, let's move along to number 7. This- 1 second, I'm trying to see if. Okay. Oh yeah, I forgot. I forgot what Dr. Carson said. That was like, ooh, doctor saying that he didn't sound too. He said some stuff that were like didn't sound too good, but. All right. Oh, sorry. I was just responding to Damaris. She wrote a direct message, so you guys couldn't read it. So here we go. How do you take the derivative here? It's an exponential function. So it's e to the something. How do you take the derivative of e to the something? Is itself times the derivative of the exponent. What's the derivative of tangent? Well, the derivative of tangent of something is secant squared of that something, but then that something is 2x. What's the derivative of 2x? 2. So you use the train rule a second time. How many of you had that right before I did it? Yes, very good. Omar, how are we doing today?
Are you talking to me or?
Yes, I think you're the only Omar here, aren't you? Oh no, we have 2. Oh, I forgot. Omar Aguilera, you're in
Yeah,
this
we went
class
through
too.
this already.
Okay, I'm sorry. Do you know how much I
No
drink on
worries.
the weekends and I forget?
Okay. Well, ignoring that, I'm doing cautiously optimistic, Professor.
Okay.
You know, for the exam, I think I'm pretty confident.
You said you're in where right now? I forgot. Omar, you are.
I'm in Fullerton right now.
Oh, but beginning of the semester, were you in another country?
Yes.
Okay. Now, okay, I was going to ask about the vaccine situation there, but I guess you wouldn't know right now, would you?
I mean, actually, no, I would. The vaccine situation over there is really good. They're opening up, and masks are no longer mandated. Most people, I think, have gotten the vaccine already. We're talking
Well,
about Israel, by
which
the way.
country
So
again? I forgot. I didn't want to see the wrong one.
Israel,
Huh?
Israel, Palestine, you know, whatever.
Oh, okay, that's where you're. Yeah, I forgot if you were there or Lebanon. I forgot. I forgot. So it's okay. Okay, but did they? I read. Okay, so it's pretty good actually. Anyone who wants to get the vaccine can get the vaccine.
Pretty much. Yeah, there's been some pretty good results, so that's that's good.
How come you guys all do these messages on direct messages? Do it so everyone can see. Because if I just respond to you, like I look like I'm talking to myself. Uh, what's my favorite drink? Daniel, you should know if you were paying attention last semester.
I was, but I couldn't remember much because I too drink in the weekend.
Okay. I actually don't drink that much unless, but when I was your guys' age, you know, when I say your guys' age, I mean like in my early 20s, and I went out, I like to get the Long Island iced tea because if you have a limited budget, they pour like 4 different liquors in there. So you get a lot of alcohol for your money. And they just put like a splash of Coke in there to give it some color to make it look like you have something. But that's what I liked.
You can't go wrong with Jameson though. Like,
Yeah.
that's pretty good straight.
Oh, I don't like the straight. I don't like really the taste of alcohol. I like what it does to me. Okay, moving on. Okay, I feel awkward talking about this because we have like Madison here, who's innocent, young kid, and
That's not the only reason you should feel awkward.
why? Everyone
Let's
else
just
is
move on
18.
with the problems, Professor.
Everyone else is 18. It's fine to talk about it. 21 to drink, but 18 I can talk about it. Isn't that the rule?
Yeah, of course.
Yeah.
Probably some underage drinkers too.
Okay, moving on. Well, it's not my fault. This was entrapment. Daniel asked me about it, and he let me to talk about it. So it's kind of like when the police set you up and you get caught, but you would have never got caught if the police didn't set you up because you would have never committed that crime. So that's kind of the thing. I would have never committed the crime of talking about alcohol if Daniel didn't bring up the subject. So it's not my fault.
That's incorrect. You did say you drank a lot in the weekend, though. So you set yourself up, Professor.
Moving on. Oh, you know what? Okay, I did do the right question. Okay, so number 8. In my morning class, I did the wrong question, but the review sheet, I did X to the sign of X, right? Let me make sure here real quick. I'm not wrong. Oh, yeah, it's correct. Okay, you have the correct. So use logarithmic differentiation. Then that allows me to use the last property here. I said the bring that exponent downstairs here. So now I'm going to take the derivative of both sides. So derivative of ln of something is that something goes on the bottom, its derivative on top. The right side, you got to use the product rule. So first times the derivative of the second plus second times the derivative of the first. So please, you guys, I see some horrible mistakes in the past. Like, don't do this, like cancel the x's out. And then just say that here we got sin plus blah, blah, blah. Then there's all sorts of mistakes. Then at the end, they have the final answer correct. How the heck does that happen? And I don't give them any points. And then they come to me, well, don't I get something? Or I got the right answer? I go, no, you're lucky I don't turn you into the authorities. All right, now we got multiply both sides by y, so we got sine of x over x plus ln of x times cosine of x, whole thing, times y. Now what is y? Well, that's the original problem. It's x to the sine of x. So y prime is equal to sine of x over x plus natural log of x times cosine of x times x to the sine of x. Any questions? Oh, no problem, Rachel. You didn't. You missed some interesting stories, and that's better. We're going over the review sheet.
Okay, thank you, Professor.
Yeah. And any question that you missed as far as the review sheet, it's on Canvas. I have the solutions on there.
Okay, I already did the review sheet, so thank you.
But I mean, if you wanted to check.
Okay, thank you so much.
Number 9. Find dy over dx by implicit differentiation. Now, remember implicit differentiation, you had a quiz where you had the implicit differentiation. Where did that go? Where did the quiz 4 key, I believe? Yeah, number 1 on this quiz, you see how you had an implicit differentiation problem. Then you have this on the review sheet, that's implicit differentiation. So if you get a quiz, if you get an exam question on implicit differentiation, you have plenty of opportunities to learn it, right? The quiz, review sheet, homework. So let's see, the derivative with respect to x. This is 5x to the 4th plus. Now I recommend that when you do this, you treat the 8x to the 3rd and the y squared as separate terms. Some people factor out the 8 and just treat it as x to the 3rd times y squared. More mistakes happen like that sometimes. So I would just say first times the derivative of the 2nd. That's 2y times dy over dx. Plus 2nd times the derivative of the 1st. Derivative of 8x to the 3rd is 24x squared. And then equals derivative of 20 is 0. So again, this is first times the derivative of 2nd plus 2nd times the derivative of 1st. Okay. Now, notice that this guy and this guy don't have a dy over dx, so I'll move them to the right side. And then the middle term right here, I'll keep it on the left. 16x to the 3rd y dy over dx equals negative 5x to the 4th minus 24x squared y squared. Divide both sides by the 16x cubed y. Now, normally you would be done at this stage, but notice the top, they have you can factor out an x squared on top. So let's factor that out. Oops. So you got the x squared here and then x cubed here. So you can cancel out 2 of the x's.
So I have a question. The directions don't say to simplify. If we would have left it like at the very top, would it be wrong?
No, I mean, usually you got to simplify in a math class. Always assume. Now, I can understand you not assuming for my class because I said a lot of the derivative problems you don't need to simplify. But having said that, on a like implicit differentiation, if you have a fraction at the end, you do got to simplify. Just if you didn't do it, I wouldn't mark it wrong.
You would have or wouldn't? I'm sorry, I didn't hear that.
What? I just give you a whole long explanation. No, that's fine. Just leave it alone. Don't. But in your next class, simplify.
Sounds good. Thank you.
I had a question exactly about that, and I asked Aaliyah too, and she was 100% on it. So Omar asked, like, if we left it unsimplified, we'd still get the credit. But what if we attempted to simplify and we messed up along the way? Would we still be granted the same courtesy as if we didn't try it in the beginning?
Madison, I need help. You're going to be my attorney. You know what? Just follow the directions. So if a question says, like on these questions, take the derivative, do not simplify, follow the directions and do not simplify. If I say then you got to simplify as much as you can. Is that what Leo asked?
You cut out
Oh.
for a little bit.
Oh my God. So you didn't hear that whole thing again?
No, it was.
Yeah,
really
the video is
out.
cut out. 1 second. Second. Or how's the video now? Can you hear me now?
Yes.
Okay. So I think it was just a temporary thing. Oh, my iPad got logged out though. Okay, so as far as the test goes, here you go. Can you guys all hear me okay? Yeah. So if the directions say find the derivative, do not simplify, then you don't simplify. If it says simplify an appropriate amount, then go ahead and use your judgment on how much we did in the class. For example, if it's a quotient rule, you would simplify the the numerator as much as possible. Implicit differentiation, you go as far as I go. So yeah, you do reduce the fraction. So the problem is when I say if you make a mistake, so the thing is in a math class, you do not want to leave an answer like at 4/6. You want to say that that's 2/3, just letting you know. Now, on an implicit differentiation, most of the time on an implicit differentiation, it doesn't reduce anyway. Like, for example, it just happens that the top here, they have an x in common. So you can factor out. But if let's say this was an x to the fourth and this didn't have the x squared, then you can't factor anything out. What if you cancel something out anyway? Yeah, then I have to take a point off. But I usually make the grading really fair. If I start taking points off because you didn't reduce it correctly, then I'm going to take points off for people who didn't even attempt to reduce it. So, but having said that, if I write in the directions, do not simplify, then do not simplify. And sometimes there's more than one reason that I ask you not to simplify. Because I want to see the step on you using the product rule on how you're doing it. We're good?
I also have a question for this problem.
No, you used up your questions. They're like between the two Omars, that's like 5 questions already.
I have a couple more. So
Okay, go ahead.
I noticed your notation. It's the 5x squared first. But in my answer, I wrote the negative 24y squared first. Would that be considered wrong? Or
no, that's the same thing. Like
if
you wrote it.
But I was just wondering like what your preference is, because I don't know. Different professors have different.
No, this is the same notation. You're saying your answer was like this, right?
Yeah.
Yeah, that's the same thing.
Okay.
And someone else might have the negative sign factored out. Yeah, it's the same thing. When I say use the same notation as I do, I'll tell you what. So someone else might write it like this with the negative sign outside of the parentheses like that. All 3 of these are the same thing. When I say a different notation, it's something I've never used before in the class, or the book doesn't even do it that way. So let me show you like a different notation and it's completely like, and sometimes it's mathematically incorrect because the person using that notation doesn't know what they're doing. So for example, let me give you a good example of a different notation. Let's go back to question number 1. sorry, actually, let's do, let's do number one. G of x, but instead of g of x, let's say it was y equals e to the 4x cubed times natural log of x, okay? So this was the first question, but instead of g of x, I wrote it as y equals. I asked you to take the derivative the way I expect you to do it, or something close to it. You go first times the derivative of the second, plus second times the derivative of the first. Derivative of the first is e to the 4x cubed times the derivative of exponent, which is 12x squared. And if I say do not simplify, you stop right there. Now, some of you might have this, might have this written over here and this written over here. And that's perfectly fine. You could have you can have this on the right and this on the left. That's perfectly fine. That's the same thing. But when I see stuff like this, hold on, I'm trying to think of a very so the derivative of y with respect to the derivative of x is equal to e to the 4x cubed times the derivative of I'm running out of room. That, and then dy over dx equals e to the 4x cubed times 1 over x plus natural log of x times the derivative of e to the 4x cubed, which is e to the 4x cubed times 4x cubed prime. Well, why don't you just tell me what the derivative of 4x cubed is? Why don't you just write 12x squared? Why do you keep dragging this out as long as possible? And then eventually, so I don't do the problems like this. So when you start writing this out, I'm like, well, what is this person doing? Now, maybe that's the way you learned it from your previous math class, but you didn't pass your previous time you took calculus, but you didn't pass the previous time you took calculus. Well, maybe you should try my way. Sorry, that's a little harsh. Oh, as far as the problem that you said, yeah, I usually put it in alphabetical order, the x first and the y, but it's not wrong if you put the y term first here, the one that you were asking about. All right. So if you're writing a term, which brings up a good point, Mark. So when you're writing a term, let's say the term is 5a to the third b squared c to the eighth. Let's say this is not even this question. The standard way to write an expression is you write the coefficient, the number, the constant, the 5 by itself. I mean, not by itself, on the first, on the left. Then you go alphabetical order. Is it wrong to write b squared times a to the third times 5 times c to the eighth? No, that is mathematically correct. This is the same thing as that. But when you write it like the second way, you don't look organized. You look, you respected. You look. Oh my God, am I talking to myself this whole time? Your video frozen. You guys read what I was saying at least? You're very okay. Moving on. Let's move on before I get frozen again. Well, I don't know what to tell you. I know the video gets cut off, but can you guys at least hear me perfectly?
No, it completely cuts off.
You know what I'm going to try to do? All right. 10-minute break. Anyone there? See if my audio is okay now?
It's working.
Okay. I restarted my computer, so hopefully that works. All right, so we'll do, what is it, 7 more minutes, and then we'll start at 4:06. All right, I'm back. Thank you. So I did implicit differentiation. Now let's move on to question number 10. Oh, that's supposed to be a cube, but doesn't look good. All right, so here we go. So the edges of a cube are expanding at a rate of 5 centimeters per second. Now, when it's a cube, this is supposed to be the width, length, and the height are the same, so we're going to call them all x. So the edge is expanding at a rate of 5 centimeters per second. So that means dx over dt is 5 centimeters per second. How fast is the surface area changing when the edge is 4.5 centimeters? So when x equals 4.5, find, I'll put A for surface area, dA over dt. Now I need the formula for surface area. So what is the surface area equal to? Well, that's the area of the surface. So the surface of one side of the cube is that highlighted side right here that I did in orange. What's the surface area there? It's x times x, which is x squared. How many of those surfaces do we have? 6 of them, right? Like a dice has 6 sides, so a cube has 6 sides. So it's 6x squared. So that's the formula for surface area on this one. So we're trying to find dA over dt. So we're going to take the derivative of both sides with respect to t. dA over dt equals 12x times dx over dt. Now we just plug in the numbers. When x is 4.5 and dx over dt is 5, so you multiply all that together, and we get 12 times 4.5 times 5, which is 270. So 270 square centimeters per second. So the question is, what if you don't know the formula? Well, you know the Pythagorean theorem, right? That you should know. You know the formula basic, like area of a rectangle or triangle. So anything different, like let's say if it was a sphere, I would provide the formula for you. So number 11. Okay. Number 11, we're doing a differential. I'll do another one after I get done with this problem, but find the differential dy for the function y equals x times, because this is a very basic question. It's not really hard. It's just dy is basically whatever the derivative is times dx. So if you know how to use the product rule here, you know how to take the derivative, right? So let's go with first times the derivative of the second. What's the derivative of 1 minus cosine of x? Well, the derivative of 1 is 0. Cosine is negative sign, but there's already a negative sign there, so positive sign of x. Plus second times the derivative of the first, which is 1. Now, that would be the derivative, but it's derivative times dx, which gives you the differential of y. So not very interesting. Remind me after you go over the review sheet, I'll do another question from differentials. You got to be able to calculate dy versus delta y, be able to use differentials to approximate a value like we did in the homework in that section. So let's do number 12 here. If you were to apply the mean value theorem to y equals 4 over x on the interval 1, 4, what will the guaranteed value of C be? So the mean value theorem, so this is continuous from 1 to 4, and it is differentiable. So let's figure out at x equals 1, y equals 4 over 1, which is 4. At x equals 4, y equals 4 over 4, which is 1. So just a coincidence that 1 gives you 4, 4 gives you 1. But anyway, so I'm just drawing the picture so you can get a visual of what's going on here. It's not required. So here's 1, 4. And here's 4, 1. And the graph is going to look like this, just FYI. It's a exponential function looking graph. Let me just I'm having trouble drawing here. Something along the lines of that. Probably a little bit more curved because at 2, it's supposed to be at 2, which I didn't quite get there, but that's okay. So there should be this, that's the slope of the line that connects those 2 points is 1 minus 4 over 4 minus 1. That's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you get negative 3 over 3, which is negative 1. So the slope of that dashed line is negative 1. The mean value theorem says there has to be some c in between 1 and 4 where the derivative at that c value is negative 1. Well, y equals 4x to the minus 1, right? I just went ahead and rewrote that right here. So the derivative is negative 4x to the minus 2, which if we rewrite it is negative 4 over x squared. Now, when is negative 4 over x squared equal to negative 1? So what I did here is this negative 1, which is the m value, that's what I put here. Let's solve for x squared. So I'm going to multiply both sides by x squared. So we get negative 4 equals negative x squared. Divide by negative 1, x squared equals 4. Square root both sides. Now x equals plus or minus 2. But since we're dealing with the interval 1 to 4, we're talking about c has to equal 2. So c has to equal 2, where f prime of c equals negative 1. And the negative 1 is from this same place I highlighted it. So at x equals 2, again, my picture is not perfect, but at that, the graph is supposed to go there, through there. So that red line, that's the tangent line at there, is the same slope as this dashed line right here. And this is the final answer. Lauren, how are we doing? All right. Number 13, find the critical numbers for the following function. So how do you find critical numbers? Well, you take the derivative, and it's when derivative is equal to 0 or doesn't exist. In this case, this is a polynomial, so you're not going to get a situation where it doesn't exist. So I want to use the product rule here. First times the derivative of the second, which is 1, plus second times the derivative of the first. What's the derivative of x minus 1 squared? Well, 2 times x minus 1 times the derivative inside, which is 1. So let me explain to you what I did. This is the first, the derivative of the second, which is derivative of x minus 3. Second times the derivative of the first. Derivative of u squared is 2 times u. Now, I did use the chain rule here, but the derivative inside is just 1, so that's why I didn't say anything. So we're going to set this equal to 0. X minus 1 squared plus 2 times x minus 1 times x minus 3 equals 0. Let's factor out the x minus 1. So you treat this as one item and this in the other. So they have the 2 times x minus, they have the x minus 1 in common. So I factor that out. Then you're left with an x minus 1 for the first term and a 2 times x minus 3 for the second term. Let's multiply out what's inside the bracket here. So it's already all factored up equal to 0. So that means x equals 1 or x equals 7/3, right? There are other ways you could do this. How about you multiply this whole thing out at the very beginning before you took the derivative? Then you took the derivative, then you set it equal to 0 and factored it. How many of you did it that way? How many did it exactly the same way I did it? Either way works. The problem with the first way is it's okay because when you multiply it out, it'll be third degree. The derivative will be second degree, so you can factor it. But what if it was like the 5th degree? And sometimes if it's already kind of factored for you, you want to leave it like that. Any questions? So just the critical numbers, they didn't ask for the whole point. You need to get the y value. Number 10 is actually, I gave you a challenging one, but I figured I'll give you a challenging one on the review sheet. So this will be easy, right? Relatively? Or would you have preferred that I save the challenging one for the test to give you worth of your money? All right. So number 14, find the absolute extrema. Absolute extrema means maximum, in case you didn't know, of the given function on the closed interval. All right. Since you're given a closed interval and this is continuous. By the way, how do you know this function is continuous? Just the FYI. Y equals x is continuous. And you know cosine is continuous. So if two functions are continuous, their sum is continuous. I never went over that property, but their sum, their difference, their product would be continuous. Quotient, not necessarily, because sometimes you're getting a division by 0. But other than that, everything's multiply, sum or difference will be continuous. So and it is differentiable. So let's take the derivative and set it to 0. So the derivative of x is 1. The derivative of 2 cosine x is minus 2 sine x. Set it equal to 0. So move the 2 sine x to the other side, divide by 2. When is the sine of x equal to 1/2? Well, we're talking about 0 to 2 pi. So let's just worry about the first quadrant first. 30 degrees, so that would be pi over 6. Hold on, I see. Your message. Which question are we talking about? Sandra, you can just unmute yourself and talk. The last question, number 13. Can you explain the one in the individual second? Yeah. So that's this. So derivative of x minus 3 is 1. The derivative of 1x is 1. Derivative of negative 3 is 0. Does that make sense? A lot of times, if you ask your question with AI, you can direct message if you prefer, but there's a lot of hard to have a question. Just let them see your question. Sometimes I don't know the question. Just don't know the answers. Then we move on. And then by the time I saw you're all over, I already answered it. All right. So, what is the sine of x 1/2 the 30-degree angle, which is pi over 6? Now, there's two quadrants where the sine is positive. First and second. Remember, the first and second quadrant sine is positive. So, let's write reference angle in the second quadrant. Here, and we talk about here. What angle is this one? 5 or 6. Are we good so far? And that's it. Third or fourth quadrant sine is negative, so it couldn't possibly be 1/2. So we list these along with the endpoints. So x equals 0, pi over 6, 5 pi over 6, and 2 pi. Remember, the endpoints automatically make it into the next phase of our problem. Now, we're going to plug every single one of these four values into the original function. The one that gives you the highest value is max, and the one that gives you the lowest value is min. Now, I do want to mention that I have this already worked out for you, right? Yeah, here. So this is all already here, and it's on Canvas. So I really don't want to do number crunching right now, so let me just show you. So when I plugged in 0 here, I got 2. When I plugged in the pi over 6, I got pi over 6 plus radical 3, which is approximately 2.25. Why I wanted to know what it is approximately? Because pi over 6 plus radical 3, I don't know what that is. I want to know like 2.25. Yes, that's bigger than 2. Like if I had to compare it between those two. So that's why I want to know what it is in decimal approximately. But as the final answer, I would give it to you as like pi over 6 plus radical 3. If I plug in 5 pi over 6, I end up getting pi over 6 minus radical 3, which is about 0.89. And if I plug in 2 pi, I get 2 pi plus 2, which is about 8.28. So looking at the outputs, that's just these numbers. Which one is the highest? The 8.28, right? But the 8.28 is really 2 pi plus 2. You really want to look at the blue. That's the exact answer. So that's why I put 2 pi plus 2 here. Where does it occur at? The x value, which is 2 pi. So that's what I did. Max at f of 2 pi, which equals 2 pi plus 2. And then the min, which I'll highlight that in yellow, I guess. What's the lowest value? The 0.89. But really, you want to write it as the exact answer, which is 5 pi over 6 minus radical 3, which would be that. So the min would be this, which is equal to that. How many of you had that, by the way, before I did it? Any of you? Really? A couple of you? Madison, you had it?
Yeah, I was stuck for a little bit, but I ended up figuring out what the answer was.
So anyway, that's you gotta know your trig in this one. It does work out okay because, you know, like for example, if they all work out, like even here, cosine of 30 degrees is √3/2. But then 2 times √3/2, the 2's cancel out, so it's just √3. And this is just 5/6. It all works out. And then the reason why you need to know the decimal approximation is so you can compare the numbers and you can see, hey, this is the largest one, this is the smallest one. Anyway, and that's number 14. So let's do a differentials problem.
Professor, I had a quick question.
Yeah.
I was wondering, are we ever going to need to specify like why something is continuous or differentiable on the exam?
No. Why? Yeah, I didn't put that on the first. If I say why it's not discontinuous, did I put that on the first exam? Like, is this continuous or not continuous? Why or why not? Did we do a question like that?
Yeah, I think there was one on the first exam.
Yeah.
Yeah.
Yeah, but differentiable, no. The only thing as far as this class goes. So let me give you an example of something that's continuous but not. So like this would be continuous and differentiable. I just want you to know it. So, but I'm not going to ask you. It's very basic. Whereas something like that's continuous, but it's not differentiable at that sharp corner there, okay?
Yeah.
And then something like, oops. Give me 1 second. Let me get an eraser here. Something like that, that's not continuous. And if it's not continuous, it's automatically not differentiable.
Okay. Okay, thank you.
Okay. So you could have a scenario basically where it's continuous but not differentiable. But if it's not continuous, it automatically falls apart. No, I'm not going to put a test question like that, but you know, you should know. So when we say, hey, to apply the mean value theorem, it has to be continuous and differentiable, meaning it's got to look like this. It can't be like that. It can't have holes in it like that. Oh, well, I didn't see the question. Oh, yeah. So I see Ryan. Yeah, cool. Thanks for answering it. The radical 3, because I canceled the 2's out. I did the work already in there. So yeah, let me go back to that question here. So you're talking about yeah. So when I plugged in when I got someone is asking about this part right here, the pi/6. When I plugged it in, cosine of pi/6 is radical 3/2, but there's a 2 here. So times 2, the 2's cancel out and you get radical 3. Thanks, Cole. You got it.
Thank you.
All right, let's do this one. I think I did a question like this for you before, but don't look at it. Hold on. Use differentials to approximate 1001. 1 second. So just to clear your, if I would just write that, everything else you got to be able to do. So I will refresh your memory. Just remember f of x plus delta x can be approximated by f of x plus f prime of x times dx. So you got to be able to look at this and say, all right, well, I need to pick f of x. Well, f of, oh, sorry, the question is cube root, not square root. Cube root. So my f of x, I'm going to call that. So the question is just what I wrote in black. So the blue and the red, you got to be able to do yourself. I'm going to say f of x equals cube root of x, where x equals 1,000, and delta x, which equals dx, is going to equal 1. So I'm going to use differentials to approximate. Now, you guys want to try doing this yourself? See how far you can take it? I gave you the formula in blue. Now, I know some of you didn't do so well on the first test. I don't not to throw added pressure on you, but you really want to do well on this test, right? Because the third test is after the drop deadline, and you really want to know how good of a chance you have. So I know the quizzes are only worth 10%, and then the participation is only 5%, and basically the majority of your grade are the tests. Because I mean, you really have to know this stuff well to get into, to be able to do well in 150, math 152, and the next one after that, and so on. I do make the exams really fair, even though some people might disagree. So I'll tell you exactly what to focus on before you leave. So, if you got like a 50% on the first test and you end up getting like a 50% on this test, then it's not going to look good. I mean, as far as chances of passing the class. So you want to make sure you do as well as you can on this one. And I'll tell you exactly what to focus on before you leave. Now, but this class, a lot of you are doing well, a lot of A's and B's and C's, but let's pick up some of the people that didn't do so well. Now, let's go over this. So I'm going to rewrite f of x as x to the 1/3. So I can take the derivative, which is 1/3 x to the negative 2/3. And I'm going to rewrite the derivative as 1/3 x to the 2/3 like that. So f of 1001 is f of 1000 plus 1, right? That's my x plus delta x. Can be approximated by f of 1000 plus f prime of 1000 times dx. What's f of 1000? Well, that's the cube root of 1000. F prime of 1000, well, that's plugging in 1000 into the derivative. Times dx, which is 1 in this case. Now, 1000 to the 2/3 is actually pretty nice because you can take the cube root of 1000, which is 10, and then square it, which is 100. So this would be 10 plus 1/3 times 100, which is 10 plus 10 and 1/300. 10 point, let me go 1 divided by 300 here. 0.00333, threes keep on running forever. And if you remember, this is a really good approximation. It actually put the first 5 or 6 decimal places is the same as the exact answer. So remember, be able to approximate using differentials, be able to know the difference calculating dy versus delta y, be able to do that. That's all in the section of the differential / linear approximation section. As far as the test goes, there'll be 10 questions. There'll be a few questions where I just say, take the derivative. Find the derivative. So there's a few questions where I'll just say, find the derivative of this, find the derivative. Do not simplify, just find the derivative. There'll be logarithmic differentiation. So study that. It's also on the review sheet. Implicit differentiation. Related rates. There'll be 2 of those. One word problem, but one basic where the equation is given to you. Absolute max min problem. It won't be as bad as the trig one that we just did, in my opinion. All right, there's some of them right there. So I'm not going to give you all 10 questions, but I give you quite a few. Oh, mean value theorem. It's the obvious one, right? So, you know what to study for. Make sure you're here on time at 3:15 Thursday to the exam with your video on, cash on the table. That's obviously a joke since we're not in class. Even if we're in class, some people take it literally. Well, you know what? I got to do a math trick for you guys. You guys look like you haven't had a math trick in a while. What was the last one that I did for you?
Gray elephant one.
Oh, okay. Let's do this one here. Please do not make a mistake like my morning class did. One person in my morning class. Pick your favorite number between 1 and 9. No, this is not the elephant. Multiply it by 2. Then add 5. Then times 50. If you're going to use a calculator, make sure you hit enter after each step. It's like don't put it all in the calculator at one time. All right, you guys caught up? Then step, you're either going to add $1770 or $1771. You add 1771.
You froze.
Oh,
Now.
okay, I'll repeat what I said. So you're either going to add 1770 or 1771, depending on if you had your birthday this year. You guys hear that? Nope.
Yeah, a little, because you broke off midway.
Yeah, I know. Okay. So add 1770 if you haven't had your birthday. Add 1771 if you have had your birthday, one or the other, okay? So you picked your favorite number between 1 and 9. You go times 2, then plus 5, then times 50. Then you either add this or this, not both, okay? Depending on if you had your birthday this year or not. Now, minus the 4-digit year you were born. So if you're born in 2001, you would go minus 2001. Are we good? Thumbs up if you can still hear me. Good? Okay. Now you should be down to a 3-digit number. The 3-digit number you now have, the first number in that 3-digit is your favorite number that you started off with. The next 2 is your age. All right, good. So before my internet cuts out, that's it. Study for the exam. Make sure you're on time with your video on, and that's it. I'll see you guys Thursday. Bye.
Thank you.